In this video, I'm going to introduce you to functions. So you've already seen a bunch of functions that are in the standard Python library of code. Print is a function. Let's see, exit, seldom used, but is a function. Input, we've used input a whole bunch. That's a function. So a function is typically going to be some sort of, it's going to be named as some sort of verb, a command perhaps, print, exit, do this thing, print this thing, exit from the code. This, I would say, give me input is sort of a longer but harder to type out name. There should usually be a verb name for your functions because it's an action, it's doing something. Every single function that you call is going to be followed by a set of parentheses. Sometimes you'll put something in those parentheses and sometimes you won't. Just actually another example of a function, a mathematical function, square root. So square root of 4 is 2. So if I set x equal to that and then print it out, if I get rid of this up here, it prints out 2. There we go. So a function, when you call it, it will often give back some sort of value. Now, print doesn't do that, right? We don't ever say x equals print, because if we did, actually, I'll even show you what that does. You can do that, but here's what print gives back, none. The value of x after this line of code is none, which is a special Python value. That means nothing. So some functions, they give you back a value, as in square root gives you the square root of whatever number that you pass to it, and you pass numbers inside the parentheses. And some functions just do a thing and they don't give anything back. So you don't say x equals those functions at all. But the purpose of this video is to show you how to create your own functions. So I'm going to create a simple function called quad that is going to, or you know what, we'll just give it a longer name, quadruple. It's going to quadruple whatever number that we give it. So it's going to return 4 times that number. Kind of a silly little function to use, but it'll give you the basic idea of what we're doing here. So first, a couple things to note. When I create my function, I start with the keyword def, D-E-F. This is short for define. I am defining a function. Then I'm going to name my function. And again, it's best to stick to verbs or verb phrases because these are actions that the code is performing. Then we have a set of parentheses. If we're going to pass any information to our function, we need to make a little placeholder for where that information is going to go. And we need to name that placeholder with like a variable name, like x. I'll show you some alternatives to this in a second. But for now, just think of these parentheses as a little mailbox where we're putting values into that mailbox that the function needs in order to do its job. Right? Quadruple needs something to quadruple. So we're going to give it a little mailbox right here named x. And then lastly, at the start of this line, there has to be a colon, full colon, to say I'm starting my function now. And then the code that's going to go inside of your function has to be indented. This is the code that's going to run when you use the name of your function. So what we're going to do is return, so that's another keyword that you may not have seen before. We're going to return the result of 4 times x. And again, there's different ways that I could have done this. I could have done 4 times x, or rather, I meant to say y equals 4 times x, and then returned y. All I'm doing here is I'm quadrupling x, and I'm going to give back the resulting value. Now it's a little bit cleaner, I think, to put this all on one line. I don't think that's too confusing, so I'm going to do that. I'm going to return the value 4 times x. So now, if I say y equals quadruple of 7, didn't mean to put that space there. It won't hurt anything if I do, but I'm going to take that out. Y equals quadruple 7, and then I print out the value of y. So I should get 28, and I do, right there. All right, so let's talk through what happened here. So y equals means I'm going to set the value of a variable named y to whatever's over on this side. Well, what's on this side is a function named quadruple. So when I run this code, what happens is Python sees this name, goes and checks for where this function was defined, so it runs right up here. And it says, okay, you've passed 7 to the function, so I'm going to put 7 as the value of x, and then I'm going to run the code. And the code is very short. All it does is multiply 4 times the value of that variable, and it returns it. Now, when it returns right here, what happens is, when it's running, this piece of code right here gets replaced by the value 28. Right? That's what the return does. Whenever you use a function's name, you'll go up into the function's code, you'll start to run it, and then the return, once it gets called, you're done with the function, you'll go back to where it was called, and you'll replace that whole piece with the value of 28, or whatever was returned, right? If I pass in 2, I should get 8. There we go. And we can also pass in variables. I could say x equals 5, and then pass in x, and now I should get 10. Because remember, if a variable shows up anywhere other than on the left side of an equal sign, so if it shows up over here, really what we're doing is we're replacing that variable with its value. So running this and getting 20 should be the exact same thing as if I put a 5 right there, because that's what happens. The value of x gets, or that the variable x gets replaced with its value before it goes and gets passed to the function. Now, I could also skip out a whole bunch of this stuff, and I could just pop it right into the print statement. I don't even need those spaces that I put in. I'm just trying to illustrate a point. And I could run it right here, and that gives me the exact same thing. I find it to be a little bit cleaner to use a variable like this at the very least, if not even another variable. You've noticed I've switched my x and my y's. That's also totally fine. Whatever gets passed in right here, it's the value that gets passed in. It's not the variable. It doesn't matter that this y doesn't match up with this x. If I run it, it still prints out 20. Actually, let's just verify that I'm printing out something other. Right? Passed in 1, prints out 4. It's quadrupled. Right? It doesn't matter that this variable name doesn't match this variable. This is a totally separate variable up here, which is a difficult thing to get a grip on sometimes. But this x is not the same as this x. Right? These are different people that have the same name, right? This is Luke, and this is some other person also named Luke, but they don't have necessarily the same value. Okay, let's look at a different function. I'm going to write a quadratic. We're just in the mood for things that begin with quad. So what I'm going to pass in is I'm going to pass in a, b, c, and x. All right, so this is for any quadratic I would want. And my general shape of a quadratic function is a times x squared. In case you haven't seen squared before, it's a double asterisk. A times x squared plus b times x plus c. And just a reminder, Python is always going to use the order of operations exactly the same way that your calculator would, exactly the same way that you'd expect it to happen in math. And then I'm going to return y. Now again, I could have done this all on one line of code. I could have just moved this until right after the return statement, but I'm going to split it up just for clarity. Now this is a little bit different. I've passed in 4 different variable values into this function. This is like if this function had 4 mailboxes where the previous function only had the 1. Actually, there's no reason for me to have deleted that old one, so I'll just put that back up there. All right, we can create multiple functions in the same file. Nothing wrong with doing that. But anyway, back to the point I was trying to make. This function has like 1 mailbox item. Right, it's going to expect 1 value to be passed to it. And this function expects 4 values to be passed to it. And then just to be consistent, I should have named that quadruple. All right, so here we're quadrupling 1. Let's now, I'm going to reuse the variable named x. There's nothing wrong with doing that. And I'm going to use my quadratic formula. I'm going to create an easy quadratic that I know what the results should be. So I'm going to pass in 1 for A, I'm going to pass in 7 for B, 12 for C, and if I pass in 3, actually let's do -3 for X, I should get 0. I believe that'll work out. So I'm still going to print 4 right here, but then I'm also going to print 0. All right, so there's my 4 and there's my 0. And I could pass in other values for x. If I pass in 0, for example, I should get 12, because 12 is my y-intercept for this quadratic equation. And there we go, I get 12 right there. All right, so you see I've passed 4 values up to this function right here. And I can pass in variables. I could pass in, now this is gonna, I don't know what the result is gonna be, but I could pass in the value of x, right? It's gonna be a 4. I know that's the value I'm passing in. I don't know what the result of my quadratic is gonna be, but let's run it and see. Oh, it's actually 4, it turns out, okay? All right, and I can pass in other values, -3, 6, 2, and, oh, 4 and 4 again. How interesting. Is that right? Let's just check this. Yep, it just happened to be 4 that time, so now it's 7. All right, so I've got 4 mailboxes. I have to pass in 4 items. If I try and pass in another item, a 5th item, there's no mailbox for it. This is going to cause an error. All right, it says type error. Quadratic takes 4 positional arguments, but 5 were given, right? It takes 4 things, but I gave it 5, and that breaks it. What if I try and give it 3 things, right? It wants 4. As you might guess, this is going to cause an error. All right, missing 1 required positional argument. It needed an extra argument, but I didn't give that to it. All right, so we'll fix this back up again. And then let's create a final example, and this will give you a little introduction into turtles, which are kind of fun things to look at and deal with. So I'm going to import turtles, or actually just turtle. And first thing I'll do is I'll create a turtle, and I'm going to name it pen. Sometimes we'll name our turtle pen or brush or pencil, or just the letter T if you're feeling a little bit lazy, you don't want to type in something longer. This is what we're going to draw on the screen with. That's why I name it pen. So where am I going to create my turtle from? Well, it's in the turtle library that I just imported up here. So turtle, and then dot, I'm going to call one of the functions from that library. And this function is actually named capital T turtle. This is a special sort of function, and you'll see that these are always capitalized. It's a special sort of function that creates an object. We're going to deal with objects way later in the course where you're going to create your own. But for now, just be aware that an object is something that can do actions and also change its own variables. And a turtle can do those things. It has its own information that it keeps track of, and it has its own commands that it can obey. So for example, I can tell it to move forward. And let's say 100 pixels. And then I can tell it to turn right 90 degrees, and then move forward 100 more pixels. And when I'm done, and at the end of all of my turtle programs, I should say turtle.done. This is really convenient. It makes it so you can actually close the turtle window. If you forget this, it's very obnoxious. So let's run it and see. All right, so I went forward 100 pixels, I turned right, and I moved down. And there's my turtle. That's what it does. But what I would like to do is I would like to write a function that draws a square. Actually, I'm just going to call it draw square. I'm going to give it a turtle named Tim. I can name it sort of whatever I want, remember? And then I'm going to tell it the size, the side length of my square that I would like to draw. All right. So what I'm going to do is, in order to draw a square, I am going to, so I'm just reusing some code here. I'm going to tell this turtle named Tim to move forward by the amount size, and then turn right 90 degrees. And then Tim's going to repeat that. And since this is a square, he's going to repeat that 4 times. I don't need to turn right that last time. I just need to draw the edge of the square. This function is not actually going to return anything. It doesn't need to. It performs an action sort of like print does. It's just going to draw the square using this turtle that I'm going to give to it. All right, so now let's try that out. So here I created my turtle. I've already defined my function. So I'm going to say draw square. I can use the name of the function and then parentheses. I'm going to give it the turtle that I just created. I'm going to create a square of size. Let's make it a little bit bigger. Let's make it 150 for a side length. And then done. And let's run this and see what we get. All right, so we drew a square. Great. I'm going to make it a little easier to see by making the size of the turtle larger. All right, and we can do lots of interesting things with this. For example, since we have this function that draws squares, so I can draw a square, and then I can tell my turtle to turn right by 30 degrees, and then I can tell it to draw another square. Which gives me a kind of cool design right here, because I'm still drawing a square, but now I have a rotated turtle, and the function doesn't mind that. Right? It doesn't know that it's rotated. It's just going to do its job of moving forward and turning right 90 degrees. So this is some of the power of functions. The goal with functions is to basically encapsulate a tiny action that is complete in and of itself. Drawing a square is a nice complete action that I'm going to box up and I'm going to put into this function. And I can reuse it over and over. Right? Here I called it twice. I could do this again. My drawing might get a little cluttered here, but I could call it 3 times and get another interesting pattern. So I hope that gives you an idea of the power of functions and how to create your own.